Hey there, ladies and gentlemen, we got our sound back, and we are now going to be doing some homework with sound. I know you guys missed my voice. Just kidding. Alright, so let's look at 15.5. Now, we're dealing with expressions, we're going to be dealing with some graphing, looking where solutions are, and this will make us so much sense more tomorrow, I think, when we really start putting these ideas together. I'm sorry, Thursday. We're going to look at this more on Thursday. So here's this deal. We had a snack bar that charges $3 for a box of candy and $5 for the combo. So we're going to be writing some expressions to represent certain situations. To do that, before we do anything else, we really need to initialize our variables. In other words, we're talking candy, we're talking combos, but we're not going to write those words out. That's crazy. Instead, what we're going to do is pick a couple variables to stand for it. So let's initialize them. So let's do this. I'm just going to pick some generic ones. Let X be boxes of candy, and let Y be number of combos. Okay. Now, I think we use C and B in class, whatever you guys chose. It doesn't really matter what. We just always have to tell the reader what in the world the variables stand for, because we can't assume they're inside our heads when we are choosing them. So let's write an expression that represents a total amount you could spend at the snack bar. Now, this is an expression. It means we're not going less than or greater than or equal to. We are just simply writing how you would calculate how much you spent. So we have $3 for a box of candy, so that's going to be like a 3 times an X. We have 5 for the combo, that's going to be a 5 times a Y. If you want the total, well, we'll add them. I mean, that's pretty obvious, right? Adding gets you the total. Over here, suppose you can spend at most $12. Now, here's the case, at most $12. So the amount you spend can be at most 12. Well, the amount I spent is right here. So this is the amount I spent, the 3x plus 5y. Okay. I can be at most 12, which means just like the problem today, we can't exceed what our aunt can tell us to spend. So this number's always got to be less than 12. Now, to pick out 3 sets of ordered pairs, x and y values that actually solve this, should be pretty easy. We just can't exceed 12 bucks. Let me show you what I mean. So let me just do like a suppose. Like suppose I buy 2 boxes of candy. Well, that's going to be $6. Well, if I'm already spending 6, I can't spend any more than buy any more than one combo, because that's $6. That's $5 total. Therefore, that's going to be 11, which is under 12. So we're good. What if I were to buy 3 candies? Well, that's going to be $9. 3 times 3 is 9. Well, that means I can't buy any combos, so that's got to pair with a 0. Flip that around. What if I bought 0 candies? Well, that would give me all the money to buy combos, but I could still only buy 2 to standard 12. So there's 3 values that actually work. Okay. Let's just see how they're going to change it on us. We want to spend at least $12. Well, that's kind of crazy. So we want our check to be $12 or more. All right. So the amount I spend, the 3x plus a 5y, in comparison to 12, has got to be bigger than or equal to, which is a kind of a big deal. At least 12 means I'm going to spend 12 or more. Actually, let's go back here. At most 12 actually means that, well, I can spend 12. I didn't think about that. Anyway, fix that in your homework there, following along. So 3x plus 5y is bigger than or equal to 12. Let's pick out 3 numbers that work. Now, this one is going to be super easy. Let me explain why. What if I were to buy 5 candies? Well, 5 candies is 15, which is already over 12, so any number I pick for y should be okay, because I'm going to be spending more than 12. So how about 5 and 1? How about 6? Well, 6 is going to be 18 by itself. That's pretty bigger than 12. So let's go with 3. Here's one that should be kind of cool. What if I go to 4? 4 times 3 is 12, which is already the same as 12. So I could even pair that with 0 and still actually hit my target. Now here's a good question. I want to spend exactly $12. Okay, crazy guy. I want to spend exactly $12. Well, the amount I spend, 3x plus a 5y, is exactly equal to 12. What's the number that actually hits that? Well, I'm going to steal this guy. Ray did the work. If I did 4 and 0, well, that's going to be 12 by itself. That means I have to buy no combos to hit my $12 total. So nothing crazy. You got to pay attention to the language, guys, and that's what this is really about. Can you pay attention to the language and kind of compare these 2 values? One value being how much you actually spent, and the other value being how much you actually want to spend. It's all about comparison, guys. That's all algebra is. Compare, compare, compare. Now, this question, I'm going to actually ignore the directions. Don't tell me the story. But I'm going to kind of give you the point of this problem. They want you to graph this thing. So here's how this is going to be graphed. We have to deal with this guy. The 3x plus 5y is equal to 12. And that's where this whole thing really starts. Now, I know it's going to be an inequality, but this question's really asking you, do you know how to graph this thing? And you do. We're going to graph 2 points, the x-intercept and over here the y-intercept. And we're going to get this from the equation, and guys, we're going to do it quick, and here's how we're going to do it quick. The x-intercept is going to be the point on this line. Well, anywhere along this line passes through 0, y equals 0, which means for this entire line, the y's are always 0. Well, if the y's are always 0, that means they're not even there, basically. So we're just dealing with the 3x equals 12. Well, 3x equals 12, that means x has to equal 4. That's going to be our x-intercept. Okay? Over here on the y-intercept, which is on this line, means it has to pass through x equals 0. The y's are different numbers, but x is always 0, which means to solve for the y-intercept, I'm just going to pretend the x's aren't there because it's going to 0 out. So I'm just solving 5y is equal to 12. Well, if I divide both sides by 5, 12 divided by 5, well, 5 goes into 12 twice, 10 to remainder of 2. So I'm going to end up with y is equal to 2.4. So 2.4 is going to go bam, bam, right there, and it gives me my line. Now, if I connect these 2 points, and I'll do so with a green line, that gives us the start of our inequality. Now, here's kind of the deal on this. We have to compare two different inequalities. Up here in this whole upper region above the line is going to be where 3x plus 5y is bigger than 12. Down below is going to be where 3x plus 5y is going to be less than 12. And you guys did a great job figuring this out. Bigger than above, smaller than below. And that's just a quick kind of tip you can use to figure out which is really fast. Whoa. Let's put this into action. We got to graph this thing. Now here's the deal. To graph this, we're going to follow 3 steps. Step 1, we're just going to graph the equation. The y equals 1/2 x minus 3. In step 2, we're going to decide if it's got to be a dashed line or a solid line, and that's going to have a lot to do with this sign right here. And then in step 3, we have to make a big decision. Are the answers we're looking for going to be shaded up or shaded down? Okay, and that's really what this whole kind of process is about. Where are all the answers located? We know there's going to be a lot of x's and y's you can pick to make this true. So instead of making a list, we're just going to simply shade, color in them, in other words. So let's start by graphing. We're just going to graph the equation. That's our starting point. That's our balance point. Now we got to kind of keep in mind this is just like the equation mx plus b. Mx plus b, that's going to be the y-intercept. That's going to be my slope. So y-intercepts start at 1 to -3. And this says go rise over run, up 1 over 2. So up 1 over 2, up 1 over 2, up 1 over 2. So now we have where our line is going to be. Let's move on to step 2. Shaded, or I'm sorry, dash or dotted. Well, here's the deal. This is going to be like a strictly greater than or strictly less than sign. It's the exclusive sign. This guy is going to be greater than or equal to or less than or equal to. Well, what's our sign? It's got the inclusive sign, so let's fill this in with a solid. So let's do that. Bam! Solid. Last part is we got to decide shaded up or shaded down. Well, here's the deal. I want y's that are bigger than 1/2 x minus 3. I want y's bigger than the line. So I'm actually going to shade up. So that's where my answers are going to lie. Up here. Now, I suck at shading, guys, so just bear with me while I try to shade this in. So what I'm trying to represent with my shading is that everything above here is actually going to be part of my answer. Now we can check this, and here's how easy it is to check it. Pick a point anywhere up here that's shaded. I'm going to be really easy and pick 0, 0. So if I use this point 0, 0, it should work in my inequality, and we can check it. So 0 is less than or equal to 1/2 0 minus 3. I just took these two numbers and stuck them in for x and y. So simplifying, I have 0 is greater than or equal to -3. Is that true or false? Well, it's in the shaded region. It should be true, and it actually does hold true. 0 is bigger than -3. Now, conversely, if I pick a number that's below the shaded region, like I'll pick this guy right here, 5, -5. Whoa. Whoa. 5, -5. And I stick it into my equation, it should, or my inequality should not work. And let's try that. So y is -5, bigger than or equal to 1/2 of 5 minus 3. So -5 is bigger than or equal to half of 5 is 2.5. 2.5 minus 3 is -0.5. Negative 5 is not bigger than negative 0.5. Which would you rather owe someone, $5 or 50 cents? So this is garbage, meaning these are not answers, but we didn't shade them, so we didn't expect them to be. So really quick, we're gonna graph the equation, decide the line, and then shade up or shade down. And if we're not quite sure by looking at the inequality, we can pick test points, and we could do it that way. So let's try this again. Okay, so step 1. Let's graph the inequality. X is bigger than, or so x is bigger than 3. We're actually going to graph x is equal to negative 3. Now, from our work earlier, x is equal to negative 3 is going to be a vertical line that's going to be right here at negative 1, 2, 3. So it's going to be this line right here that I'm kind of temporarily dotting in. I don't know if it's going to be dotted or not. We're just kind of working that. So next decision, should this line be dashed or dotted? Well, that's going to have to do with the sign. Dotted lines are going to be signs like this. Solid lines are going to be like this. Well, if you look at the sign, this should be dashed. So let's go ahead and dash it in officially. Okay. Now the last part is, should I shade to the right or shade to the left? Well, look at our inequality. I want x is bigger than negative 3. Bigger than negative 3 is on the right, so I should shade to the right. Okay, next question. Bam. Go forward, man. Okay, so solve the following inequality for x. Support the work, or go ahead and show and do the work. So here's the deal. 8x plus 7 is bigger than or equal to 11. It doesn't ask me how I'm going to solve this, so guess what? I'm going to do it by hand because I don't have a graph handy. The graphing is kind of complicated anyway. I'm just going to solve it by hand. So I'm going to pretend like it's an equation unless we multiply or divide by a negative, in which case we flip the sign. Now, I don't see any negatives here. I don't think it's going to be an issue, but let's go ahead and find out. So the first thing I'm going to do is subtract 7 on both sides. That leaves me with an 8x, and that's going to be a 4. And then, of course, I'm going to divide by 8. Divide by 8. Those cancel. X is going to be bigger than or equal to 2. Now, I didn't divide by negative, so I'm going to leave the sign alone. That's what I'm looking at. Okay. Alright, so short homework tonight, guys. I hope it helped. If it did, please tell your friends. Get them on here. Get them to do some homework for the love of God. It would help us out so much and make the class so much better. So encourage them, prod them, cajole them, threaten them. I don't care. Get them on here. Get them doing homework. Guys, I'll see you guys tomorrow. Have a great night.